Very good afternoon, students. I hope everybody is fine. So, I would like to welcome you all to this 5-day online class for the International Space Olympiad 2024. So, first of all, I want to welcome our tutor for the 5-day camp, Ms. Shanti, to this session. So, welcome, ma'am.
Thank you so much. Thank you so much.
So, before starting the session, I would like to give a small introduction to Shanti, ma'am. So, we have Shanti Krishna is today to lead the sessions. So, she is an MSc in physics with specialization in theoretical physics, and she have done an internship at JAXA. Right now, she is doing a PhD at CSIR, National Institute of Oceanography. So, over to you, ma'am. Dear students, all the best for your sessions. Thank you.
Yes,
Hello, everyone. Am I audible to you?
ma'am.
Very happy to see a bunch of kids, talented kids, who is on the way to become astrophysicists, cosmologists, space enthusiasts, right?
Yes, ma'am.
Yeah, yes.
Yes.
I hope every one of you is having very much fun studying about space science, right? Am I right?
Yes,
Yes.
Very
ma'am.
good. Yes.
Yes.
Then hold your breath. We are about to discuss about space for the coming 5 days. Okay, starting from today. I am very happy to see you all people who are very dedicated and very interested in studying astronomy, astrophysics, etc. So today in this session, we will be mostly dealing about solar system. We are not moving to cosmology or into technical parts, but we will be considering a solar system as a whole in our sessions. Okay, so today we will be studying about how the solar system was born, the components of solar system, and the coming days will take up each of the planets and each of the components of solar system, and we will study everything. Okay, are you
Okay.
ready?
Yes, ma'am. Yes.
Yeah, that's the spirit. I already am loving the class. I'll share the screen. Please wait. Can you see my screen?
Yes, ma'am. Yes, ma'am.
Very good.
Yes, ma'am. Yes, ma'am.
Very good. Very
Yes,
good.
ma'am.
Yes. So, who can tell me the important components, I mean, large scale components of solar system? It contain, um, yeah, it contain dwarf planets. Yeah, that's right. Then meteors. Yeah, asteroids. Very good. Comets. Yeah. Then yeah, there are a lot of components, right? Starting from the largest to the smallest dust particles. Yes. So why is studying about solar system important to us? Because solar system is actually studying about ourselves. Because we are in solar system. Earth is a planet, and the you know the life on Earth or the Earth itself depends a lot on the sun, on energy, and if sun is not there, of course Earth is not there. So solar system, and not just the sun but every other planets are gravitationally linked, and the whole system is connected. So it's very important to study about that, because if you study the past of solar system, you will know what happened to the solar system already. It will give us some idea about what will be happening in our solar system, right? So that affects our future also, because we are on Earth. We haven't been living on anywhere else. Just we were visiting. Sometimes we visit the orbit on Earth. Some and maximum distance we have visited is around Moon. So studying about the solar system is very important. Okay, let's see how the solar system was born. Yeah, here you can see the position of solar system in Milky Way. That the solar system, a part of Milky Way galaxy, consists of sun, 9 planet. I mean, actually 8 planets, right? It's only 8 planets, then 64, many moons, many asteroids, millions of comets, meteoroids, and interplanetary dust and gases. Now, let's talk about the theory behind the solar system origin. Here you can see there was a cloud of gas. Actually, every star is born in a nebula. Nebula is nothing but a cloud of interstellar dust and gases. Okay, maybe you have heard about Crab Nebula, Horsehead Nebula, etc. Right? These are the famous nebula which whose pictures were taken by Hubble Space Telescope. So these nebulas, what they are doing? See, in the nebula, there are mostly hydrogen gas. So whenever there is a hydrogen gas, what happens? It's moving, right? These gas particles move. I can hear some noise from somebody. Let me see. Can you, if, yeah, I'll mute them. Yeah, very good. Yeah, so whenever there is gas molecules, they won't sit still, right? They'll move. They'll move, fastly, and they'll hit each other. When they hit each other, they, stick together, and in layman, in normal, like in simple notion, we can say they stick together and will form a ball of gas. Once this ball of gas attain a certain mass, what will happen? The gravity comes into play, and then the whole nebula starts to contract. When the stars contract, what will happen? When these gases in the nebula contracts, the pressure increases, right? So when something is, contracting, when the pressure is increasing, what will happen? Of course, the temperature will rise. So as this is happening, at some point, the whole big, it will be very, very massive. Okay. You know what is the mass of the sun? I can tell you what is the mass of the sun.
About 10 million kilometers.
Mass is measured in kilograms.
Yeah. 10 million kilograms.
Yeah. 10 million kilograms. Okay, then any other guesses?
Ma'am, may I say?
Yeah.
It's actually like 1,000th of the mass of Jupiter, but I don't know the exact mass.
1,000th of the mass of Jupiter. Actually, see, Sun
1,000.
is 1,000 times the mass of Jupiter, you say?
Yeah.
Okay, it is actually way more than that.
It's
Okay.
10 raised to the power of 32 million.
Very good. Very good. Yeah.
Okay.
It's 10 to the power 30. Actually 2 into 10 to the power 30, which means 1 followed by 30 zeros. That much kilogram. That is the mass of the sun. So a lot more mass is there when it is nebula, and the whole nebula, when it contracts, in the core of those nebulas, what will happen? Temperature will rise. At some point, when the temperature is about 10 to the power 9 Kelvin, Kelvin is the unit of temperature, right? When it is 10 to the power 9 Kelvin, something starts. Can you tell me what is starting then in the core of the nebula?
Hydrogen and helium fusion.
Not hydrogen and helium, but hydrogen and hydrogen fusion. It's partially correct.
Ma'am, nuclear fusion?
Yes, that is nuclear fusion which is happening.
Nuclear fusion.
Yeah, here you can
Nuclear
see in the
fusion.
picture. Here you can see in the picture, see, all the gases are coming to the center, right? It's contracting. So the pressure is increasing. But here what will happen? The fusion will happen. When the fusion happens, opposite force will be there. That is the radiation force. So when this gravitational force is equal to radiational force, thus a star forms. Our sun is formed like that. Okay.
Yes, ma'am.
Yes.
all the dust particles and all till like 4.5 billion years it took to form a baby protostar in the
Actually,
center.
5 billion years ago, the solar system formed. Earth was formed some 4.6 billion years ago. Anyway, we will study
Ma'am,
about
before
Earth. Yes, please.
and before that also sun was formed nearly like 4.5. Before that
Yeah,
also.
5 billion years ago, the whole solar system was forming. Yes, that's right. And now,
Ma'am,
now,
I have a doubt.
yes, please.
Ma'am, what was the mass of the nebula which was the solar system created from?
It is said to be more than like almost 2 into 10 to the power 30. More than that, because we don't know the exact mass of that nebula, but it should be more than that of the sun, right? So almost 2 into 10 raised to 30 kilograms. That much massive.
Ma'am,
Okay. Yes.
there is also something said about the Big Bang theory also, right?
No, Big Bang theory is about the origin of universe. We are not talking about the universe as a whole, but we are just taking a very, very, very small part of it, the solar system.
Okay.
Yeah. The universe
Ma'am?
was, yes.
Ma'am, I have a doubt.
Yes, please.
Ma'am, what is the name of the nebula that solar system was formed?
Solar nebula. It's called the solar nebula.
Okay.
Yeah. So that's how the solar system was born. It's called the nebular theory.
Ma'am?
Yes.
Ma'am, can I tell a fact?
Yes, please.
Ma'am, if universe was a year, we are in the first January's first millisecond.
Sorry?
If universe was a year,
Hmm.
we are in January
Ah,
first millisecond.
yes, yes.
The cosmic
Now,
calendar. Is that the
yeah,
cosmic calendar?
yes, it is. So now let's have a look at the planet formation. So according to the condensation theory, the planets formed in 3 distinct stages. The first two applies to all planet. The third applies to only the Jovian planets.
Ma'am, I have another doubt.
Yeah, please.
Ma'am, why are the outer planets are gaseous?
Yeah, we are about to talk about that in the coming slide. Okay.
Ma'am, I think is it because that the more massy objects, the particle which had more mass condensed together and formed the terrestrial planets first, and then all the gas which was remaining created the rest of the planets?
No, ma'am. It was
Uh,
like
it
the silicon and like hard metals which can resist the sun radiation. The baby protostar, which is right now sun's radiations,
So can you
they
please do one thing, everybody? First of all, Raghav, please don't scribble in the screen. Nobody, please, please, it's a request, don't scribble in the screen. And the second thing, I will give you a time for question answering in the end of the sessions, okay? So in between, if you have any doubts, you can write in the chat section. Fine. Or just note down in a paper, and in the end of the session, you know, the whole 10 to 15 minutes will be allocated for question answers. Is it fine?
I have a doubt. Ma'am, I have a doubt.
So is it okay that we ask the doubt in the end of the sessions?
Okay.
Yeah. So otherwise our portions won't be finishing. So everybody please cooperate. Thank you so much. So we were talking about the planet formation. The doubt earlier which was asked why the Jovian planets are gaseous. It's a very important question and we will be dealing about that in this and coming slides. So it's called the condensation theory, how the planets were formed. Altogether we can divide it into 3 distinct stages, and there are first 2 stages which applies to all the planet, and the third applies to only Jovian worlds, which means Jupiter, Saturn, Uranus, and Neptune. So the first stage one is the dust grains in the solar nebula form condensation nuclei. So some there were a lot of dust particles remained after the formation of the sun. So these clumps then stick to other clumps, causing the clumps to grow in size rapidly. So if there was a lot of molecules which stick together and another set of molecules which stick together, actually when they are moving, they hit each other, and then they both these clumps stick together just like that. And then there is a process of accretion, which is the gradual growth of objects by collision and sticking. So that happens around the sun, and it created objects a few hundred kilometers across. So it's just like a accretion disk. That center, you imagine sun, and there is a disk-like thing, just like what to say, the rings of Saturn.
Frisbee.
A lot of dust particles are being, here and there, it is revolving around the sun. And then what happens? These at the end of the first stage, solar system consisted of hydrogen and helium gas and millions of planetesimals, objects size of small moons and having gravitational fields just strong enough to affect their neighbors. Then there is a second stage. The gravitational force between planetesimals caused them to collide and merge. So these small particles collide and merge and become larger objects. Because larger objects have stronger gravitational pulls. You may have studied the law of gravitation in your classes, right? Which means,
Mass is directly proportional.
yeah, the force of gravitation is directly proportional to the product of the masses and inversely proportional to the square of the distance between them, right? So it is directly proportional to the masses, which means as the mass increases, the gravitational force also increases. So because the larger objects have stronger gravitational pulls or field, eventually almost all of the planetesimal material was swept into a few large protoplanets. So these protoplanets are accumulations of matter that would eventually evolve into planets we know today. So the asteroids and comets originated as collisions between planetesimals and protoplanets, sent out the small chunks of material that escaped capture. Just like, if you have a big ball of clay and a lot of small balls of clay, and if you are throwing this small clay into the big ball of clay, then what will happen? A part of the big ball of clay will be, removed from it, right? And it will fly off. Just like that, these comets and asteroids are formed just like this flying, planetesimals, parts of planetesimals. Yeah. So after 100 million years, we have 9 protoplanets, dozens of protomoons, glowing protosun at the sun, at the center. So it's not fully formed, but we have a lot of planetesimal, and in the center there is sun. So roughly 1 billion years were required to sweep the system clear of the interplanetary trash. And now we know that it all have emerged into 8 planets, starting from Mercury, Venus, Earth, Mars. Then there is a asteroid belt, and after that we have Jupiter, then Saturn, then Uranus and Neptune. And after that we have trans-Neptunian objects that include Pluto and other Kuiper belt is there. And after that we have a cloud of solar system objects. Yeah, that's called the Oort cloud. That is a whole picture of our solar system. Now,
Ma'am, I want to add something.
Yeah, yes, please.
Ma'am, that when the solar system was formed, there were total. Right now, there are total 4 terrestrial planets. That's Mercury, Venus, Earth, and Mars. But before there were 5 terrestrial planets. which were, and there was one which was formed, that it was known as Theia, and Theia was a planet which and
Yeah,
Theia,
we will talk about Theia in our Mars class. I mean, Earth. When we study about the Earth and Moon, we'll study about Theia.
and
That's right.
also
Yeah.
and
Thank you
also
for the details.
yes, and also, ma'am, you were saying that all the objects collided and formed planets. Where they collided because there was no center of mass that time when a supernova exploded near our solar system disk, and it gave.
Okay. Supernova explosion, that's all hypothesis actually. It's not proved completely. So we'll talk about that in another session, okay?
And there was
Ma'am, can I
no.
ask
Okay.
question?
Yeah, I'll give you time for question answers and this kind of facts, okay? In the end of the session.
Ma'am.
In the end of session is fine?
Okay, ma'am.
Yeah, thank you so much. So then there is making the Jovian planets. So there are two conflicting views on how the Jovian planets formed. The first view is four largest protoplanets became massive enough to enter a third stage of evolution, sweeping up a large amount of gas directly from solar nebula. The second view is the giant planets formed through instabilities in the cool outer regions of the solar nebula, mimicking on small scales the collapse of the initial interstellar cloud. So actually, how did the Jovian planets form? Actually, if you look at what is this Jovian planets made of, you'll get it's mostly hydrogen, right? So, after the formation of the sun, when the sun was so young, it was so, energetic. It was providing a lot of energy, a big solar wind, a strong solar wind actually. So all these lighter elements, it flew away because of the solar wind. The solar wind actually swept these lighter particles into the outer solar system. That's why in the inner solar system we have heavier elements mostly, which is made of these terrestrial planets are made of this heavier elements, while in the Jovian systems and in the icy planets, they were formed mostly of the lighter elements like hydrogen and helium. So this is why the Jovian planets are mostly gaseous.
Ma'am, I have
Yes.
a doubt.
Yes, please.
Ma'am, why are Jovian planets bigger and they have rings and they have more moons? And why terrestrial planets have no rings and they have lesser moons?
Yeah, that is actually a valid question, but I can tell you, this so sun is actually a very powerful gravitational field holding solar objects, right? So whenever the sun is there, we can't have a lot of mass in it, and the whole lighter element things, it was swept out of the solar system. I mean, in the inner solar system. So there were enough and more objects found in the outer solar system than the inner solar system, because in the inner solar system whatever were there, almost it was attracted by the sun. For example, why Mercury is the smallest planet? Mercury doesn't even have a crust. Mercury and Venus, do they have any moons? No, they don't have any moons. Only Earth has a moon. And then Mars has two moons, but they are just potato shaped, small asteroids, nothing compared to our moon. So the thing is, sun is a larger, gravitational pulling machine, and it almost sucks out all what were there in the vicinity of it. But what happened in the outer solar system, there were materials left, and it was mostly these lighter elements. So there was an enough materials available there for those planets to form bigger. Okay, then if you have any doubts, no problem. We will be covering all those doubts in the I think 15 more minutes I will take class, and after that you can ask questions. Okay, don't worry about that. In between, after 10 minutes or so, I'll give you some 5 to 10 questions time. Now, I would like to talk about general characteristics of the solar system. So the general characteristics of the solar system include, about its planetary orbits and rotations include planet and satellites orbits are in common plane. I mean, it's in the same plane. If you can see in the picture, Pluto is a trans-Neptunian object, so don't worry about that. But all the other planets, they are in same plane, right? And almost all these planets revolve around the sun, which is same to the direction of the rotation of the sun. Not all planets, but almost all of the planets. I'll tell which planet moves opposite direction.
Uranus?
Venus and
Uranus,
Uranus.
ma'am.
Venus and Uranus.
Ma'am, Venus and Uranus. Venus. Venus and Uranus.
Venus and
Venus.
Two planets. Really?
Venus and Uranus.
Venus
and Uranus. Ma'am, Venus.
Only Venus.
Only Venus.
Yeah, only Venus spins backward compared to most of the other planets.
Venus
can I
is
take a fact also?
Venus's spin motion is 180
Uranus-
degrees flipped, right?
Yeah, Uranus, it's
90
not,
degrees.
I'm asking about the revolution. So Uranus actually rolls around, which means the axis tilt is 90 degree, which means it almost rolls around the sun. But there is only one planet which is revolving in the opposite direction, that is Venus. Anyway, all of the planets revolve around in the same direction to the rotation of the sun. Then now we have some other general characteristics. For example, the chemical and physical properties of the planets. The terrestrial planets, which include Mercury, Venus, Earth, and Mars, they are small and have a high density and are composed of rock and metallic elements. Then there is jovial planets, which are large and have a low density and are composed of gases and frozen compounds. Now there is another characteristic that the sun's rotation. Actually, the sun's rotation is very slow. There will be, and in tomorrow there will be another slide. We will be talking about the sun, where we will discuss that sun is revolve. If somebody asks like, what is the rate of sun's rotation? We can't say that directly, because different different parts of the sun rotates in different speed. I mean, the equator part, just have you seen the different layers of Jupiter, stripes of Jupiter? Just like that, different stripes of the sun rotates in different speed. The polar, the stripes near the polar section, it revolves faster than that of the equator section. So almost you can say how many days? Any idea?
What was the question?
2 days.
What was the question?
The rotational
Nearly
period of-
25 to 30 days.
yeah,
Sun's rotation is.
yeah, it's almost 20, 24, 25 to 30. On an average, you can tell, 25 days or so. So it takes that much time for a sun to revolve a single time. Now, when we talk about the meteorites are visitors from outer space. And meteorites are believed to be pieces of material that originated in the formation of solar system about 4.6 billion years ago. Oh, I want to tell you one thing also. Somebody said meteorite when we were talking about the what to say components of solar system. I would like to correct that. In the space there are many smaller particles, smaller asteroids, which are roaming around the solar system. They are called meteoroids. Okay, They are called meteoroids. So these meteoroids, when they enter the atmosphere of the Earth, we call it meteor. Okay, maybe you have heard about meteor shower, right? The meteor
Yes,
shower.
ma'am.
Yeah, it is also called the
Yes, ma'am.
shooting star,
Yeah,
right?
ma'am.
Have you seen, anybody have seen shooting stars?
Yes, ma'am.
Yes,
When
Ma'am. Actually, I
Ma'am,
had saw a
ma'am,
meteor shower accident, ma'am.
Oh, okay,
No,
that's luck.
ma'am.
ma'am, shooting stars are actually just meteors which are falling down, like
Yes.
smaller parts of meteors. Ma'am, at my home when I went to my village, and I was sleeping at 1 o'clock just because I wanted to see Jupiter in my telescope, and I saw it also. After that, when I slept, I just saw a meteor shower, like all the and like that.
Yeah, very good. So yeah, in
Ma'am,
the village
ma'am,
parts you can see this meteors and meteor shower, because in the city parts what happens, there is light pollution, right?
Yes,
Yeah.
that becomes
ma'am,
a layer of
can
light.
I tell you a fact, ma'am?
Yeah, please.
Ma'am, actually, there were no. If because of Jupiter's gravity, there was planets stop being formed, ma'am. Otherwise, ma'am, if Jupiter wasn't there, ma'am, there would be more planets, ma'am.
Yeah, the asteroid belt, it should have been a planet, but since the Jupiter is so big and the gravitational pull is so huge, that's why it
Strong,
couldn't
ma'am.
form a, yeah.
And ma'am,
Also, ma'am,
can I say also? Ma'am, can I also say
Yeah.
a fact?
Yes, please.
Ma'am, due to if some asteroids just leave gravity of the Jupiter, you know, and sometimes they also hit on Earth. So some of those asteroids were part of Mars also, became Mars moons.
Okay.
Now,
So
ma'am, one
now,
more part. Excuse me, ma'am.
yeah, yes, please.
I didn't understand one thing.
Yeah,
Ma'am,
please.
what is the difference between meteorites, asteroids, and comets?
Yeah, I'll tell you. It's beautiful actually. One thing, comets are entirely different different object. Comet is actually, you may have heard, it's actually an icy thing. Okay, dirty ice. That is the nickname given to comets. Comets are actually,
No, ma'am. Snowballs.
There is a Guinness World Record created of a comet which that its icy tail was like long, like 300 kilometers.
yes. So let me, yeah. Yes, let me complete this. Can I complete answer the question?
Ma'am, comets are hard. They are not icy.
Ice is hard. Okay. Oh,
Ma'am, they are
sorry.
rocky and hot.
He's saying it's hot. He's saying it is
Hot.
hot.
It's actually it's not hot actually. So why do we see comets shine? Because when it is coming, there are many volatile particles present in the comet. So whenever it is coming fast towards the sun, all these particles, it will just um start due to the solar wind, it will just become gases, and as its direction of the solar wind is opposite to that of the direction of the coming of the comet, it looks backwards. That's how the tails of the comets are formed. It's actually ice. It comes from Oort cloud or Kuiper belt. Okay, so they are very icy. So once they reach the nearby the sun, or say maybe when it is affected by the solar wind, this happens. Okay, that is comet. Now asteroid, they are just like any rocks, bigger rocks, smaller rocks in the solar system. It's called um what to say asteroids. So meteoroids are the same. But when it enters the atmosphere of the Earth, we call it meteors. And most of these meteors will finish off while it enters the atmosphere, because whenever it enters atmosphere, there is heavy friction, right? In the space there is no friction, but in the atmosphere there is friction. So due to this friction, heat will generate and it will be like a fireball. That's why we see a fireball like thing, flashing of light. But sometimes, if the meteors are, if it is very large, a part of it can fall on Earth. So if we retrieve back this kind of a part on Earth, we call it meteorite.
Yes, ma'am. There is like an asteroid which name is FOBs or NOBs something. Because it's very large, Jupiter also can't stop it from its gravitational force, because it said that Jupiter is the guardian of Earth for asteroids. It's like his big brother. And but but NASA is launching some nuclear missiles in their rocket, which goes to and changes the
orbit.
orbit of that
It's not
asteroid.
nuclear.
So
It's still
anyway, we'll come back. We
missile.
can come back to the slide. And here you can see an example of meteor. Did you understand the difference between meteoroid and meteorite?
Yes,
Hopefully it is. Yeah, very good.
yes, ma'am.
Yes, very good.
Yes,
And now,
ma'am.
yeah, you can see a meteorite here, and you can see a crater here, right? A crater is formed when a meteor, when it is larger enough to penetrate the atmosphere, and if it hits, it forms, a pit like this called craters. You can see a lot of craters in moon. Why?
Because the moon does not have an
because
atmosphere to
the
form
moon
it.
is the protector of Earth. Because it's the
moon
protector of Earth,
protects
as it
from
has
Earth from
protected it from
Moon
all
protects
other asteroids and
from thousands
the
of
other
asteroids.
objects.
That's why it has
because
It,
this
moon
picture.
doesn't
Ma'am,
have
Earth
an
is an
atmosphere.
atmosphere. The asteroids burn up in the atmosphere.
very good. That's the answer actually. See, why we can't see a lot of craters on Earth, while near the Earth moons we can see many craters, because moon doesn't have an atmosphere. So every meteor which reaches the moon, it fall on it makes a crater on it hits on the surface. So that's how there are a lot of craters seen on the moon.
Ma'am,
Yes,
also there were many craters on the Earth, but they just
yes,
all the wind blowing and all just
yeah.
buried it.
Ma'am,
And
there's a crater
now Earth has an atmosphere also. Before it didn't have an atmosphere.
Ma'am,
Ma'am, plus the
Yes,
moon could be also called as the
ma'am,
protector of Earth, as it has protected it from many asteroids.
okay,
Ma'am,
yes,
I know a fact. Ma'am, one meteor was like so big. It's still in Aurangabad. I quite don't remember the
yeah, I
place.
know that. Yes.
Ma'am,
Lonar Lake. Lonar
Yeah,
Lake.
Lonar Lake, that's it.
it's a very big hole.
Mm.
It
It's
turned into a
Lonar
block.
Lake. Lonar Lake. There's a similar lake. There's a similar lake in other continents.
Yes, there are.
ma'am.
So yes, yes,
a
please.
basaltic lake.
The asteroid which had killed the dinosaurs, ma'am, it actually collided in the Gulf of Mexico, ma'am.
Yeah, ma'am.
Okay.
And its name was
It created a very big crater, ma'am.
yes,
Mm-hmm.
and its name was Chicxulub, ma'am.
Ma'am, I have a
Okay.
question.
Yes,
The
please.
Ma'am,
meteor
I
size
will
was 10
just
kilometers,
is
ma'am.
it I want to just know or what is ma'am, in the Mexico there is a zone called the zone of silence. Is there because of an asteroid which hit there and changed like something of the
No.
because
No.
Ma'am,
Yes.
and
I
also
actually I didn't
when
get
there are
the
when there are missions when they are required to return back to Earth due to the Earth's atmosphere, they can burn up. That's why there is an additional heat shield which is required. But it is not the same if you need to
Yeah.
land on the moon, because the
Mhm.
moon does not have an atmosphere.
Yeah, that's right. Mm.
So in the Apollo missions, the command module needed to have a heat shield, but the lunar lander didn't need to have a heat shield.
That's right. Now, I think let's move to the next slide, right? I will just share the screen. Is there any other question from the previous slide?
No, ma'am.
Okay. Yeah, now we know how the solar system is born, right? So from the previous slide, can I ask you some questions?
Yes.
Yeah.
Yes.
Mm-hmm.
Yes, ma'am.
Yes, I'll ask some questions from the previous slides. So the first question is, what is the nebula where the sun formed is named?
Solar nebula.
Solar nebula.
Solar nebula.
Solar nebula.
Solar
Solar nebula.
Solar
Okay.
Solar nebula.
Okay, that's
Solar
right.
nebula.
Hmm. So the next question is, what is the name of the theory which talks about the formation of a solar system called?
Condensation
theory.
Nebular
Condensation
condensation.
theory.
Condensation
Mhm.
theory.
Condensation theory. Condensation theory.
Condensation theory.
Actually, it's called nebular contraction, nebular theory, and the which planets are formed. Okay, see, the idea that planets form from such a disk is called the nebular theory. How the planets were formed as such is called the condensation theory. Okay. The next question I will ask. Do you know the average distance between the sun and Earth?
1 AU.
Yeah,
Ma'am,
1
yes,
AU
ma'am.
is called
Astronomical unit.
Astronomical unit. Astronomical unit.
1 AU 93 million miles.
Okay. That's right. It's 1.4 into
0.4
8.
into.
Yeah. 10 raised to 8 kilometers, right?
Yes,
Yes.
ma'am.
Yes, ma'am.
Very good. Very
Ma'am,
good. Now let's
149.6 million kilometers.
okay. Now let's move to the next slide. Our star, the sun. So these are the vital statistics of the sun. The mass of sun is almost 2 into 10 raised to 30 kilogram. The visual radius is 6.96 into 10 raised to 5 kilometers. It is actually the mass of sun when compared to mass of earth is sun is 3.3 into 10 raised to 5 times the mass of earth. And the visual radius means, sun, it's not like at some point the sun is like finished. It's not like that. Like sun have different layers, and sun has a corona. Corona we cannot see, right?
Yes, ma'am.
Only during the total solar eclipse we can have a look at it. Otherwise we can't see. We can see up to photosphere. So that is the visual radius, we say, the radius up to the photosphere. So it is actually 109 times the radius of Earth. So if 100 Earths are joined together, 100 Earths, then we will get a sun. That big is the sun. Yes. So the equatorial rotation period is 25 days. Yes. Now, the sun is the largest object in the solar system, and the sun contains more than 99.85% of the total mass of the solar system. Now, if you put all the planets in the solar system, they would not fill up the volume of the sun. 10 Earths or 10 Jupiters fits across the diameter of the sun. So I think you have almost understood the size of the sun, right? You can imagine how big is the sun, right?
Ma'am, I have a doubt.
Yes, please.
Ma'am, the question is, the sun contains more than the 99.85% of the mass of the total solar system, but we are talking about the solar system till Neptune or till the whole Oort cloud.
Full Oort cloud.
Ma'am, then the sun would be very small by the size if we take whole Oort cloud.
Sorry? Huh?
If we take the whole Oort cloud,
Huh?
then the sun would be very small.
Why?
Excuse me, can I?
Ma'am, because the total solar system is like more very big from the sun.
Total
But
solar system.
may
No,
I?
we're not talking about the size of the see. It says that if you join together 100 Earths, you will get the size of sun. But you are talking about the mass of the sun. The sun contains, which means the mass. Sun weighs more than any objects in the solar system.
Okay.
I mean,
Okay.
it's a mass we are talking about, not the size.
The Oort cloud's mass is about 3 multiplied by 10 raised to the power of 25 kilograms.
Ma'am, the size of the Oort cloud is 2 light years.
Okay. Yes. Now let's move to the next slide. Yeah. Now, the sun, when it was Galileo who found with his refractive telescope, which was made by himself, he found that the sun, every day we see sun, right? Every day the sun looks similar to us, but to the solar scientists who are study, who study about the sun, for them sun is acting differently in different minutes of the time, because sun's activities, for example, and the number of sunspots in the sun, all those things, it actually changes as time, one year to year. It was found by Galileo that there is a activity cycle of 13 years, that the sunspots will be prominent at some point of time, then gradually it will decrease, and then it'll come back. That a cycle is there, and there is a cycle for solar activity also. Now let's have a look at the sun's interior. In the center you have a core, and after that you have a radiative zone, and then there is convective zone, and in the end of the in the surface of the earth we can see the photosphere.
Ma'am, I have a fact that the corona is like something about 2 to 3 times hotter than the surface of the
Yeah,
sun.
that is true. Actually, the surface of the sun, which is only some 6,000 or 5,000 Kelvin. Actually, 6,000 Kelvin, only that much. But corona is much more hotter than that. There are actually many scientists who are studying about it, but
Yes.
it's
Nobody
not
has still
yet.
discovered the
Yeah, it's
true
not
reason.
yet discovered. So if you people, if you take up astrophysics, and then if you found it, it will be big thing. Even scientists till now doesn't know, like, how is that possible. There are many theories, of course, but they are not, which is the final thing, it's not finalized.
Ma'am, I
So
have a fact
yes.
that people used to think that the Earth was the center of the solar system.
Huh.
But
Yeah,
then
at some, not just the
Nicholas,
solar system, the center of the universe. Earlier people used to think so, right?
yes, ma'am, and Nicholas Copernicus found
Yes,
out the
ma'am.
heliocentric model, but no one believed him. And but after like half century, then Galileo came in, and then he proved through that there were phases of the Venus, like there were of the moon, and that happened only if the sun was the center of the solar system.
Yeah,
Yeah.
it was a number of scientists like Nicholas Copernicus. For the first time, he introduced heliocentric theory. That's right. And then, but he was, nobody believed him. Then there was Kepler, who knew that the sun was center of the solar system. And then there was, of course, Galileo had equipments. Galileo had many things to prove that sun is the center of the universe. Actually, after it's the 17th and 16th century, people, before that, people used to believe that Earth is some special place in the universe because we are there, humans are there, and there are things revolving around the Earth. Like there is a goddess who who has a number of threads hanging from her fingers, and in each threads there are different planets, including different stars, even sun, and it's her who is managing all this revolution system around the sun, around the earth. But later it was understood that there was no goddess who is doing this job. She'll be bored, right, doing all these revolution if there was one. And then of course, that time the administration was not impressed by the heliocentric theory. So that time it was the church who was administrating the whole country back then in the European um, regions. So at that time, yeah, it was very hard for Nicholas Copernicus and people like him to prove and to publish that this is happening. Not the Earth is the center, but the sun.
he was
Yeah.
a
Yes,
Polish
ma'am.
astronomer,
Also,
right?
ma'am, I want to talk about the
Yeah.
universe that everybody believed before in the 16th century, as you said, that the earth is the center of the universe. But
Yeah.
now it is not believed, or is it that nobody knows that is the earth center of the universe or something else is the center of the universe? Many telescopes are made to see the Big Bang, but there is a problem in the telescopes that in which direction you point out, at that direction it will show you the center of the Big Bang.
What do you think? Which is the center of the universe? What do you think?
No,
Anybody
ma'am.
has any answer?
Ma'am, maybe it could be a black hole.
Yes, ma'am, I also think Ma'am, that can it I could also be think? a black hole.
It would be hard to
Ma'am,
find a
avoid.
black hole. It would be hard to find a black hole of the amount of gravity you're thinking of.
Ma'am, it would be a void.
Ma'am, it is all around us, right?
Ma'am,
Very good. It's
there-
all
I
around
think
us.
very
Let me tell
massive
you.
black hole.
Let me
Ma'am,
tell you.
probab-
See,
Ma'am,
Ma'am, can I also
it's
say?
all around us. It's everywhere and anywhere because all this space was confined within a singularity once, right? So all this space we are talking about, if some explosion happens in our room or on Earth, we can find this that is the center point from which this explosion happened. but it happened in a system where there is space. But in the case of Big Bang, there was nothing. No space was there beyond the singularity. Everything that we see, every mass that we see in the universe now, it was all confined within that very, very small infinitesimal space. So that's, if you are talking about a space time where the center of the universe we are finding, there is no such thing, because everywhere and anywhere is a center.
According to us, the edge of the universe is the what is it called, the CMB, cosmic wave background, because when light travels until there, then it is so many light years away that when light will travel there, it would take all the time which for which the universe has been there.
Actually, cosmic microwave background radiation is not the edge, but it is everywhere. It's like a cloud. It's like, that is the basic temperature of the universe. It's like a cloud. Like if we see, look to take a picture of universe from any side, say from right, left, any top, down, any side, you will get this background radiation. It's not an error, but we will get that because it is the temperature of the universe from a very old age, almost like 3 or 4 Kelvin. Okay, so now let's talk about the sun.
Also, ma'am, the universe has
Yes.
something about 1,000 light years or something, a hole at the edge of that universe, and it's like said that two universes collided each other, and in our universe there was a hole created at the edge.
Anyway, that is cosmology. We are, yeah, when we get enough time, after the classes, maybe we'll discuss that. Okay. Can we come back to our slide?
Yes, ma'am.
Yeah. So the energy generated in the core of the sun propagates outward through these different layers and finally through the atmosphere of the sun. This process takes tens of thousands of years or more. Now, sun's atmosphere also has these layers, which is, it's the sun's atmosphere we are talking about. This is the interior of the sun we are talking about. So here we have a photosphere where the average temperature is 5,800 Kelvin, almost 6,000 Kelvin. And there is chromosphere above that. It is a red layer observed during a hydrogen filter. So filter in the sense, when you look at the sky, we cannot look with naked eye, right? We have to use different filters to look at the sky. And if you use a hydrogen filter, you will get another red layer around the photosphere of the sun. That's called the chromosphere. Temperature at that region, temperature of chromosphere is 10,000 Kelvin. And then there is the temperature of corona. It's incredibly thin outer atmosphere, the corona, but the temperature is really high. It's almost 10 raised to 5 Kelvin, right?
Ma'am, I have a doubt.
Yes.
Ma'am, why the photosphere is the surface of the sun, right?
Yeah.
Ma'am, then why is corona's temperature more and photosphere temperature less?
So that is a $1 million question. We don't know yet.
Ma'am,
Yes.
ma'am, can I tell a theory about the question he said?
Hypothesis, right? Please tell me.
Ma'am, actually, I have made around this session.
Okay.
Ma'am, that actually sun is so active that there are continuous sun solars and many solar activities are continually formed during the process of the sun's hydrogen nuclear fusion. So there are many solar storms, solar activities happening. So it is released into the space, and they are so hot that they affect the thin atmosphere corona, that is incredibly thin outer atmosphere, and the temperature is raised after the contact of the solar storm with corona.
But this photosphere is also having in touch with the solar wind, right? The solar
Yes.
storm. So why photosphere is not getting a high temperature? Just corona is getting high temperature.
Ma'am, because the sunstorms, solar storms are formed not on the photosphere but later deeper than the photosphere.
Yeah, but it touches the photosphere to reach the corona, right? And it is not staying in the corona, but it is moving away, right?
Yeah.
Ma'am, I think is it because because the corona is so hot, it is pure heat energy, and you can't because you can't see energy. We can only see the photosphere directly because the corona has very less particles and is very hot. It is more energy than particles.
No, that's right. Actually, that's why we cannot see the corona, because something is visible. How is something visible? When light is, reflected from there, then only we can see the things. But the particle density at corona is all, it's actually very thin, and the particle density is really less. That's why we cannot see that. That's right. Yes.
Excuse me, ma'am.
Yes.
Ma'am, I had a doubt saying
Yes.
that the sun is actually white in color, right? So why can we see it yellow in color when we observe it through Earth, like from the Earth's atmosphere?
Why sun is white in color? Why did you say that?
Because in most books which I read, it was written that the sun is actually white in color.
Yes. Why is that? That's actually right. Tell me why.
Actually, my doubt.
Okay, actually, I'll tell you. See, sun emits all the lights, all the from red, that VIBGY or all the colors are emitted by sun. Have you seen a color disk? In color
Yes,
disk,
ma'am.
if you rotate the color disk very fast, if you see all the colors together, white is formed, right?
Somewhat.
Yeah, it's not somewhat. When all the colors are mixed in the particular proportion, we can see the white color.
Ma'am, in the prism.
Yeah. So
Also, there
sun
was
is emitting all these colors. That's why we see the sun as white in color. Okay.
ma'am,
Then yeah.
we are talking about solar flares, and right now I just created a joke because the joke is that Earth, people say sun wants to kill us with its solar flares emitting by the solar flares of it. Meanwhile, sun protecting us from the cosmic rays of its heliosphere.
Okay. Now, yeah, but I didn't answer that question properly. Can I answer it first?
Okay, ma'am.
Yeah. So the actual color of the sun is white. But the sun's light enters the atmosphere and reach our eyes, right? So when it enters the atmosphere, it gets scattered. The atmosphere scatters blue color more. That also you know, right?
Yes, the UV rays, ultraviolet rays.
Not even the ultraviolet rays, but the blue light. Ultraviolet rays has just having a frequency more than that, right? But even I'm just talking about the visible blue light. Even
the
that.
ozone layer, right?
Sorry, no, it's not the ozone I'm talking about. See, why do we see the color of sky as blue? Because the sun's rays, when it enters the atmosphere, most of it is scattered, and since the blue color is scattered more than that of the red color, we see the sky as blue. But since all these blue color are already scattered, when you see the sun, the disk, what we see is the reddish color, because all the blue color is already scattered, and what is reaching to our eyes is the red color. Understood? That's why we can see yellowish red colored sun.
Thank you, ma'am.
Yeah, no problem.
Excuse me, ma'am.
Yes.
Ma'am, ma'am, I am having a theory about Sol 2025 that there will be, ma'am, a solar storm in 2025, and ma'am, that solar storm will be so powerful that, ma'am, it can cause electricity outage for months.
Also,
Okay.
right now, just due to this heat, the scorching heat and solar, the Delhi just broke the record temperature of US, which is 52 degrees Celsius temperature. In Delhi, it was 54 something.
Anybody is from Delhi in our class?
Ma'am, me.
Okay. How is the temperature there? Is it too hot there?
Yes, ma'am.
Okay. Actually, I am, yeah,
Ma'am, in my place it is so much rainy.
rainy. Which place is that?
Ma'am, Guwahati. Ma'am, Dispur.
Okay, Dispur. Fine. Yeah, I'm from Kerala. We do have rain here too.
Here it is slightly cold.
Okay.
Excuse me, ma'am, in
Yes.
Pune there's normal temperature.
Sorry?
Right now,
Ma'am,
In
I am
Pune, the temperature is normal.
here,
Okay.
ma'am, temperature is normal. It's because it is evening. Otherwise, 2 o'clock it's like 46 something.
Which place is that?
Gujarat, ma'am, Ahmedabad.
Okay. Okay.
Ma'am, in Pune, like it's a little windy in the evening, and like in the afternoon, it's a little hot. It goes like 36, 38 degrees Celsius over here. And in the night, the wind breeze is like so cold. It reaches up to like how much? 18 degrees Celsius or like 6
Oh,
that.
okay.
Ma'am, in Delhi it is 45 degrees.
Oh God.
Se-
Ma'am, in Nagpur also, it is, ma'am, like 45 degrees Celsius.
Okay.
Ma'am, it is
No,
also
ma'am.
rainy here
It
and
is
Normal
52.
temperature in Pune.
Okay.
ma'am,
In Pune,
ma'am,
it is
ma'am,
always hot, but it looks like it is about to rain, but it not never actually rains.
Yes, ma'am.
Okay.
Same in our place also, ma'am.
Okay. But
ma'am,
when the cloud,
Yeah,
when there is cloud cover, the temperature will increase because the rays which is coming inside the atmosphere won't go outside because of these clouds. So
ma'am, sometimes in
yeah.
ma'am,
afternoon, it will go ahead, dispute touches 40 degrees Celsius.
Okay.
ma'am, in my
And
Here,
place,
right
every
now,
time
it's
there will
something
be
about
white clouds, ma'am. But it will feel like it will be it will come, it will rain in like 10 or 15 minutes, ma'am.
okay.
ma'am, here it's like 33 degrees Celsius.
Okay. So here you can see an example of sunspots. So everybody be careful in the heat waves, okay? So if you are going out, do not go in the peak hours. Yeah, take care of yourself.
Miss,
Yes.
this is happening because of a process called El Nino.
Yes,
El
El
Nino.
Nino. It's an oceanic process which is happening in the
Yes.
Pacific.
Pacific
It,
Ocean.
Yeah.
like this.
Global warming.
Yeah,
Due to
Yeah.
global warming, it is also happening.
Yeah.
El Nino
Ma'am,
means the little
sunspots-
boy of Christmas.
Yeah, that is
Ma'am,
right.
Ma'am, sunspots are the coldest part of the sun, right?
Yes, that is right. They are the coldest, there are cold parts. Those parts are seen in dark colors. That's why we call it sunspots.
Ma'am, polar
ma'am,
flares
they
are
are 1500 Kelvin. Ma'am, La Nino is the dangerous version of El Nino.
La Nino and El Nino are two kinds of, oceanic processes which happens mostly in the Pacific, in the equator region of the Pacific. Yeah.
Ma'am, I have a doubt.
Yes.
Ma'am, like when I was in the school, I was like, when I got to know about this El Nino, me and my friend who were very curious in this atmosphere, like this all about Earth, we just skipped our activity and games and started to study about it and started to make theories.
Okay.
Ma'am, can I ask my doubt?
Ma'am, the
Yes, yes,
sunspots
please.
are 1500 Kelvin.
Okay, that's
My
right.
doubt is what is the duration time of that El Nino? Like after how many years this happens?
It's actually not cyclic. It comes, sometimes 6 years, sometimes 7 years. So it's scientists couldn't find a cyclic periodicity in it.
Okay.
Yeah.
It's
Ma'am,
like 2024 right now El Nino is like started
Mm.
something like in March it started.
ma'am, solar flares are produced from sunspots.
Okay, now there are different terminologies when you talk about the sun. There are different, due to the sun's magnetic field, it creates many atmospheric phenomena in the surface of the sun. So let's study about that. The first one is prominence. So this is prominence, solar prominence. Have you heard about solar prominence? So it is a large and bright feature which is extending towards from the surface, just like you can see. It's like a part of very part substance from the sun surface itself. It's coming out, right? So it's a bright feature extending outward from the sun surface, and these are actually there are it's anchored there you can see it. It's not moving away from the sun as a whole, but it is attached to the sun. Two legs are there, it is attached to the sun, and it is moving away from the surface. So it is attached to the photosphere of the sun, and it extend outwards to the sun's outer atmosphere. It is actually extending towards the corona. So this is what we call prominence. And now the next thing is solar flare. So what is solar flare now? So what to say?
Ma'am, we are hearing like something vibrating sound, ma'am. That's a little.
Yeah. Okay. Let me see from where it is coming. And now it is not there, right?
But ma'am, sometimes like someone unmutes their mic and this vibrating sound.
Okay.
Ma'am, I have a
Yeah.
doubt.
Yes,
Can
please.
you can you explain prominences one more time?
Yeah,
I
I can explain that one more time. So they are large and bright features which are extending outward. Large and bright features extending outward from the sun's surface. That is what we called the prominences. It is attached to the sun's photosphere, and it is what to say extend outwards the corona of the sun. So this is a prominence.
Ma'am,
Thank
can
you,
I
ma'am.
ask one doubt?
Yeah, sorry.
Ma'am, can I ask one doubt?
Yeah, please.
Ma'am, why are sunspots formed?
Yeah, we will discuss about that. Okay. After just these 2-3 terminologies, we'll discuss about the sunspots. Don't worry.
Okay.
Okay, yeah. So about solar flares, they are they are actually bursts, intense bursts. It is radiating from the sun's surface again, photosphere actually. Actually, they are intense bursts of radiation coming from the release of magnetic energy associated with sunspots. So there are magnetic energy stored which is associated to the sunspots. When it is bursting outwards, intense bursts of radiation, we call it solar flares. Okay. Yes.
Yes, ma'am.
Now, yeah. Now, about the sunspot. You already asked about sunspot. I'll take that slide. Where is it? Yeah. So this is the sunspot, right? So they are actually, it's not permanent features. They are temporary spots that we see on the solar disk. So consider this is a solar disk. There we can see, here you can see a sunspot. Here there is a sunspot. So these spots, temporary spots seen in the solar disk is called sunspots. Now they are darker than the adjacent area, right? Actually, they are the regions of reduced surface temperature. Why they are formed? Because of the concentrations of magnetic flux. It is the magnetic energy which is playing there. So whenever there is an active region of magnetic activity and magnetic flux, then if you can see it, no sunspots are seen isolated. It is seen between in pairs, right? So it's like two different poles of the magnetic fields are attached to these two sunspots. So yeah, understood. It is the areas where the magnetic field is about 2500 times stronger than Earth's. Is a region of strong magnetic field.
Ma'am,
And
I
it
have
is,
a doubt.
yes,
Ma'am, are sunspot placed differently above the photosphere or below the photosphere or connected with the photosphere?
it's seen above the photosphere, but the activity is happening within this photosphere.
Oh,
We can see it in the surface. I mean the surface of the photosphere. But the activity, the magnetic
Ma'am,
field related activity is happening within the photosphere.
is the photosphere like a hole? Sorry, photosphere, no. The sunspots.
Sunspots. No, it's not a hole. It's
Ma'am,
just the region. Just the height difference is not there, but the
it is
temperature is less than that of.
because the sun, like the heat, I know that it's above, but it's showing that the lines are curving inside the black portion.
Yeah, that is true. The lines are curving in, but it's not a
Ma'am,
lower
does
elevation place. It
the
is.
each photosphere or black sunspots have a name?
No, because it is temporary feature, right? Each tide will come and go. We see a sunspot in one region, and in the other region we can't see it. Maybe in the same region, if you check
Day by
after
day
some
it
days, yeah.
changes. Day by
Sorry,
day it changes.
it's not
Day by
day
day.
by day, by months it will take.
Okay.
Yeah. Okay.
Excuse me, ma'am. What is
Yes.
umbra and penumbra and sunspots?
Yeah, umbra and it is. I'll show you a picture of umbra and penumbra along with the sunspot. Then, yeah.
Ma'am, there is also a tumbra.
Okay, I'll show you umbra and penumbra. See this? The
Yes, ma'am.
region here,
Yes,
this
ma'am.
darker region is called umbra, and this lighter ones are called penumbra. Okay.
It is like umbra and penumbra of a shadow, right?
Ma'am, I was going to say
Yeah.
that.
Yes.
Umbra and penumbra for the shadows.
So the penumbra is the outer, relatively light region of the sunspot. This is the penumbra. It is shaped like a ring around the darker and cooler umbra. Okay. Umbra
Yes, ma'am.
is actually the inner, dark, cool region of the sunspot. It can be up to 12,000 miles. Penumbra is a region around the umbra. Okay.
Ma'am, it's also used in
Thank you,
solar
ma'am.
eclipse, right?
Sorry?
It is also used in solar eclipse, right?
Yeah, yes, that's true. Now here you can see different, smaller sunspots. They are called pods. They are smaller sunspots, but they may be not having the penumbra. It's just the umbras here.
Yeah.
Yeah.
Ma'am,
Yes.
you said that something extends up to 12,000 miles, but I didn't hear what was that.
The umbra region of the sunspot.
Okay, thank you.
Yeah, the magnetic field within the umbra region is very strong. Okay, and then there is another called granulation. So what is granule? You can see granule-like formation, right? So they are solar granules together with intergranular lanes, like dark and cooled areas between granules where solar material is descending into the surface. So there are objects, sinking into the surface and somewhere descending into the surface. So this happens everywhere. So which forms that, what is coming in, going inside will be having lesser temperature than that of what is coming outside. So there is granule-like formation. So what is causing the sunspots? The sunspots occur where the sun's magnetic field loops around of the solar surface and cool it slightly, making the section less bright. Okay, that's how the sunspots are formed. These disturbances in the sun's magnetic field make the sunspot about maybe say 1500 degrees cooler than the surrounding area. Hopefully it is clear. So bye everyone.
Bye, ma'am.